In the past week alone, thousands of earthquakes have shaken a small region of the Czech Republic, right in the heart of Europe. At first glance, this might sound alarming, even ominous. Earthquakes, Europe, magma. But the reality is far stranger and far more fascinating. Because while magma is involved here, it isn't moving, it isn't rising, and it certainly isn't about to erupt. In fact, the magma linked to these earthquakes has likely been sitting completely still for hundreds of thousands of years. Let's explain what's really happening beneath the ground and why this region keeps shaking again and again. An ancient magma body frozen in time. Deep beneath northwestern Czech Republic, at around 12.5 kilometers below the surface, lies an ancient magma intrusion. This body of magma likely formed around 250,000 years ago, during the region's last known volcanic eruption. At that depth, cooling is an incredibly slow process. Even magma that stops moving can remain partially warm for hundreds of thousands, or even over 1 million years. But here's the key point. This magma intrusion is stationary. It's not rising, it's not expanding, and it's not feeding a volcano. So if the magma isn't moving, why are there earthquakes? The real culprit, volcanic gas. The earthquakes are almost certainly being caused by carbon dioxide, a volcanic gas, migrating upward from even deeper magma sources in the Earth's mantle. As this gas rises, it doesn't simply drift upward harmlessly. Instead, it forces its way through fractures and faults in the crust. But rising gas alone usually isn't enough to trigger massive earthquake swarms. This is where things get weird. When gas meets ancient magma, the carbon dioxide appears to be passing through or near the old magma intrusion, right within an active fault zone. When pressurized fluids move through fractured rock, they can reduce friction along faults. That makes it easier for the rock to suddenly slip, producing earthquakes. This interaction between a rising volcanic gas, ancient magma bodies, and active faults creates the perfect conditions for what's known as an earthquake swarm. 2 phases, thousands of quakes. Since November 20th, the earthquake swarm has unfolded in 2 distinct phases. Phase 1 occurred between November 20th and November 27th, centered within a tiny half-square kilometer area about 3.2 kilometers east of the town of Luby. After several days of continued background seismic activity, Phase 2 began on December 4th, about 2 kilometers north-northwest of the first location, and it's still ongoing. This second phase has been roughly 6 times more intense in terms of the number of earthquakes recorded. Why most people felt nothing. Despite more than 5,000 earthquakes, most people nearby felt absolutely nothing. That's because over 99% of these events were micro-earthquakes, smaller than magnitude 2, far below what humans can usually detect. Only about a dozen earthquakes were strong enough to be weakly felt by people directly above their epicenters. The largest quake so far? Just magnitude 3, strong enough to be recorded, far too weak to cause damage. What exactly is an earthquake swarm? Unlike typical earthquakes, these events don't follow a main shock-aftershock pattern. Instead, earthquake swarms involve many quakes of similar size occurring repeatedly in the same small area, without one dominant event. Interestingly, the term earthquake swarm was actually coined in this very region. In the late 1800s, a scientist studying an 1824 earthquake sequence in Vogtland realized that these events behaved differently from normal earthquakes, and a new term was born. A region that shakes, again and again. The Vogtland region is one of Europe's most active swarm hotspots. In just the 21st century, major earthquake swarms have occurred here in 2000, 2008, 2011, 2013, 2014, 2017, and now 2025. Some of these swarms have lasted weeks, others months, and a few involved more than 10,000 earthquakes. Most never produced quakes larger than magnitude 4. However, history shows that stronger events are rarely possible. In 1985, one swarm produced a magnitude 5.1 earthquake, so while the risk of damage is very low, it is not zero. Why this area is so unique? To understand why this keeps happening, we need to zoom out. Much of Central Europe, including this part of the Czech Republic, sits atop the European Cenozoic rift system, a region shaped by passive rifting rather than violent plate collisions. The specific structure beneath this area is called the Egger Graben. This rift creates thinner crust, deep fractures, and unusually shallow partial melt in the upper mantle. Compared to surrounding regions, magma here doesn't need to rise very far before releasing gases, gas, faults, and pressure. As partial melt releases carbon dioxide, the gas travels upward along fractures created by the rift. When pressure builds, it can trigger earthquake swarms, cause localized gas release at the surface, and repeatedly activate the same fault systems. Despite the shallow depth of these earthquakes, there is no realistic path toward a volcanic eruption. The magma involved is ancient. The gas is escaping, not accumulating, and the system has behaved this way for centuries. So, should anyone be worried? In short, no. These earthquakes are small, expected, and well-studied. They are part of a long-standing geological process, not a sign of an awakening volcano. But they do offer something else, a rare glimpse into how magma, gas, and tectonics interact beneath stable continental regions. And that makes this swarm not dangerous, but scientifically extraordinary. Earth's most fascinating activity doesn't always come with lava flows or towering eruptions. Sometimes it comes as thousands of tiny shakes, quietly revealing the ancient forces still at work beneath our feet. And in the Czech Republic, those forces are very much alive. If this helped you understand what's really happening beneath the surface, hit like and subscribe. It really helps the channel.